Hello, welcome to Chapter 9, Lesson 9. Today we're going to be talking about multiplying fractions by whole numbers, right? So the fractions are the numbers or the values between the whole numbers. And so what would happen if we multiplied them? We could use models and equations to multiply a fraction by a whole number. So let's take a look at how we would do this. All right, so our first example here says each card on a trivia game has 6 questions. Each question represents 1/6 of the questions on the card. Caleb correctly answered 4 of the questions. What fraction of the questions on a card did he answer correctly? I know you guys are probably sitting here saying, wow, this sounds tricky, but listen. If each card has 6 questions, so that means there's a total of 6 questions. That means each question is worth 1/6 of the questions on the cards, right? If I answer 2 questions, 2/6. 3 questions, 3/6, and so on. Okay, so if we think of it that way, maybe it's not quite so difficult. And below here, it tells us what we're trying to do is we're trying to say, what is 4 times 1/6? Now, this is what I was talking about when we were trying to find equivalent fractions, and you would tell me if I was going to just take like 1/6 and multiply it by 4. We do not get an equivalent fraction. It has to be by 4/4. Okay, and so now today we're going to discover why. What happens when we multiply by just 4? So one way is we could use repeated addition, right? 4 times 1/6. So let's say I wanted to do 4 times 5. That was our first way of doing it, is I could do, 5 plus 5 plus 5 plus 5, right? We could do repeated addition. Okay, so don't think of 1/6 as like this crazy thing. It's just a number. I'm just saying I want 4 groups, and there's 1/6 in each group. So I have to add 4 1/6 together. So we would get 4/6. Okay? So that if we simplified 4/6, I could divide by 2, and get 2/3. So 2/3 would be our simplifying answer, which means 4 times 1/6 is equal to 2/3. Okay, so another way is we could use models. Now, using models are great, but doing math is much better, right? So it says the number line shows the first 4 multiples of 1/6. So 1 times 1/6 is 1/6. 2 times 1/6 is 2/6. 3 times 1/6 is 3/6. 4 times 1/6 is 4/6. Okay, so if we think of it that way, again, we'd get 4/6, which if we reduce, we'd get 2/3. Okay, and here's a model down here that shows that 2/6 is equivalent to 1/3, so that means 4/6 is equivalent to 2/3. 2/3. All right, so up here you can see it says you can use equations and properties to multiply a fraction by a whole number. I don't know, it's kind of an interesting way to look at it. So what it's saying is if I take 5 times 3/10, okay, if I'm looking at 3/10, I could say it's the same as 3 times 1/10, right? So then if I'm taking that and I'm multiplying it by 5, I can use the associative property and like switch them around and do 3 times 5 times 1/10. Okay? So therefore, if I do 3 times 5, that's 15 times 1/10. 1/10. And 15 times 1/10 we know is 15/10. Okay, so if I am going to, I see that's improper, right? It's an improper fraction. So what I can do is I can break that apart into 10/10 plus 5/10, right? And this is equivalent to 1. And then 5/10 I can reduce, divide both by 5s, and get 1/2. So 1.5 would be what I would get there. Now, listen, you guys, there's like a 5,000 times easier way to do this, but this is kind of interesting to me. You know, we're practicing our properties doing it this way. So that's neither here nor there. So 5 times 3/10 is 1.5. And it says the product lies between the whole numbers 1 and 2, right? So if I was going to put this on a number line, I'd get 0, 1, 2. So 1.5 would go right here on a number line, 1.5. This would just be regular old 1/2, right? And this would be 1.5, our mixed number. Okay, what does it say down here? The numerator of the product is the same as the product of the whole number and the blank of the fraction. And the numerator. Look at this. Look at this. Did you see that? The numerator of the product, which is this guy here, is the same as the product of the whole number multiplied by the numerator of the fraction. 5 times 3 is 15. Yeah, see, now this is where we're going, you guys. 10 doesn't change because we're not cutting the pieces into smaller sizes, right? We need the same size of piece. And the denominator of the product is the same as the denominator of the fraction. Okay, let's dig into this a little more. Here's what all I need to do. Ready? So I like to think of it like this. 5 is the same as 5 over 1. So if I line things up like this, okay, we multiply numerators. 5 times 1 is 5. Multiply denominators. 1 times 8 is 8. So 5/8, I ask myself, can I simplify? No, I cannot. 5/8 is simplified already. So 5/8 is my answer. Okay, so 4 over 1 times 2 over 3. Okay, so we're going to do 4 times 2 is 8. 1 times 3 is 3. Now this is improper, so I have to see how many 3/3 I can take out. 3 over 3 plus 3 over 3, so that'd be 6. Right? Can I fit another 3 in there? Nope. Plus 2 over 3. Okay, so I've got 1 plus 1 plus 2/3. Right? So it would be 2 and 2/3. Right? Does that make sense? Because remember, when we're adding fractions, we add the numerators. 3 plus 3 is 6. 6 plus 2 is 8. Thirds, our denominator doesn't change, so same goes. We're multiplying by a whole number. Okay, I just wanted to do some of these examples, so when you see them on your independent practice, you're like, oh, I got this. Okay, so for number 7, it is 5 over 1 times 7 over 10. Are you ready for this? I don't know. I don't know if you're ready for this or not. There's another trick called simplify before you multiply. Okay, ready? Watch this. If we're looking crossways, look at this 5 and 10 here. Okay, what I can do is I can simplify. I can divide by 5, divide by 5, cross out, I'd get a 1 and a 2. So now I'm multiplying 7 times 1 and 1 times 2 to get 7 over 2. Then I'd have to make it an improper or a mixed number, right? If I didn't want to do that, I can do it normal ways. If I don't see that quite yet, we'll practice that more. I can just do 5 times 7 equals 35. 1 times 10 equals 10. Okay, let's see if we get the same answer. So if I break this guy out, I get 10 tens, 10 tens, 10 tens, and 5 tens. Okay, so it'd be 1 plus 1 plus 1 plus 5 tenths, which we know can reduce to divide by 5, 1/2. So 3.5. Or let's see what we would get here. 2, 4, 6. Look at this, 3.5, because we'd get 1, 2, 3, plus a half, 3.5. So we're going to get to the same answer, but if you simplify first, you can only simplify up and down and crossways. So kind of like making a bow tie here. Let me erase this so you can see it a little better. Okay, so what do we have? 5 over 1 times 7 over 10. So if we make a bow tie, that is how we can simplify. We cannot simplify this way and this way. Anyways, so we get an answer of 3.5, and then it asks us what the product lies between blank and blank. What two whole numbers? So 3.5, if I put it on a number line, 0, 1, 2, 3, 4. That's just like our normal number line. 3.5 is going to be right here between 3 and 4. Okay, so I just wanted to do a quick example on that one so that you would know what to do when you got to it on your assignment. If you need help, as always, you let me know. And I will, that's all I have for you for today. So we'll see you next time. Bye.